Hello students, greetings of the day. I am John Livingston, Assistant Professor of Computer Science and Engineering at Comrade College of Engineering and Technology. The topic we are going to discuss in this video lecture is recursive functions in Python. So these are all the lecture content for this video lecture. The first slide is what is recursive function is, and the next we shall see about why are recursive functions are very important, and the next slide what are the when to avoid the recursive function we shall discuss, and in the next slide we shall see about applications of recursive function followed by syntax and example of recursive functions. So what is recursive function is? Before seeing what is recursive function, we should know what is function is. We all know that function is nothing but a block of reusable code. Function is a block of reusable code, and this is the syntax of the function. Any function will start with a keyword def, and it is followed by function name, parameters and block of code, and all the function will result some result. Okay, it will return some result. So this is the syntax of function in Python. So again I want to insist what is function is. Function is nothing but a block of reusable code. So then what is recursion is? So the recursive function contains two words, recursive function. So we have learnt about what is function is and what is recursion. So what is recursion is nothing but something refers to itself or repeats in a self-similar way, or we can say in a programming language paradigm we can say that function that calls itself again and again is called recursive function. Functions which calls it again and again is called recursive function. So why are recursive functions are very important? In programming, recursive function is very important because the recursive function turns the complex problem into simple and elegant code. Recursive functions main advantage is what? It will change the complex problems, complex coding problems into a simple and elegant code. Also in data structures this recursive function is highly used. So data structure is one of the very important topic or very important concept or very important domain in computer science. So in data structure we have lots and lots of concepts to learn. So in that data structures we are having the sorting, searching and backtracking. For these types of sorting, searching and backtracking concepts in data structures, this recursive function is very useful and important because recursive functions reduces the code and it makes the complex problems into a simpler problems. So recursive function can be applied in data structures, as well as recursive functions is used in trees, graphs and linked list. So these are all the concepts in data structures. So in data structures this recursive functions, the usability of recursive function is very high. So when we should avoid recursive functions or recursions, recursive functions should be avoided in these cases when the problem is very simple. We don't need to go for the recursive functions, as well as when a problem has lot of functions calls. If we are having many function calls, we shall avoid recursive functions, as well as when the performance is the main thing or very critical. Okay, if we need a high performance, we shall reduce the usage of recursive functions, because when we are using recursive function every time, in all the time, it may reduce the performance of the code. Okay, so this is the applications of recursive function, as already we have dealt with. It is used in data structures, especially in Sudoku solving, NQ problems, then word search puzzles and chess game. While we are coding for these types of concepts, especially chess game, word search puzzles, NQ problems, Sudoku, we use this concept recursive function for coding these things. This is the syntax of recursive function def. So this is the starting of a function, and this is function name along with a parameter. In recursive function this is very important. A base case condition should be mentioned. A base case condition should be mentioned to stop the recursion. A recursive function is the one, it will call itself again and again. It is calling it again and again. In a certain point we should stop calling it again and again. So this is the condition. When yes, a condition is satisfied, when this base condition is satisfied, calling it again and again will stop. So if you are not writing this base case condition, it will go on loop, it will go on infinite loop, it will call it again and again, and it will never stop. Okay. So base case condition is very important to stop the recursive function. So this is function name, this is base case condition, the return value of base case result. Then this one is very important. Why? Because here only we are having the recursive function call, RFC, recursive function call. This function name and this function name should be same. So this function calls the same function. So this function name and this function name should be what? Same thing. So this is the syntax of recursive function. We shall see one simple program, example program, factorial of a number. So what is factorial of a number? Factorial of 5 is what? 5 into 4 into 3 into 2 into 1. 5, 4, 3, 2, 1. It should be multiplied. So this is the program. Just see here, this is the starting of recursive function. This is the name. This is the name of recursive function. Factorial is the name of the recursive function. You see here in this place, here is also the name of the calling function is what? Factorial. So this name and this name should be same. This name and this name should be same. So in this line, fifth line, this function calls itself again and again. This is called recursive call. Okay. So let's see each and every line, what is happening here. So the starting of this program happens in this line, sixth line, print function factorial of 5. So this is called function call. You might have aware of that. This is called function call. So the 5 is placed here. So n is equal to 5. Then this 5 is moved to here. If n is equal to 1, you have to return 1. So in this case n is equal to 5. So this block is wrong. So we cannot run this block, right? When this block can be run, when the n will become 1, this block is true and it will be running, it will be executed. So in this case, in this first case, when the function call first happens, the value of n is what? 5. So n is equal to 1, this is wrong. So this code, this piece of code will not be executed. So else part will be executed. In else part we have to do what thing? Return n into factorial of n minus 1. Okay. What is happening here? N is 5, you know that, into factorial of n minus 1. What is that? It is 4. Okay. 5 into factorial of 4. We don't know what is the value of factorial of 4. So what we have to do? Again we are performing a recursive call. This 4 is placed here. The function call itself again and again. So the 4 is placed here. It is a modified value. First value it is 5. It is sent by this place to that place, and when we do the recursive function call, 4 is placed here. So each and every recursive function call, the parameter will be what? It will be what? Modified. Okay. So first 5 is going, we don't know what is the answer is. Then the 4 will be going to the n value. Then 3 will be going, 2 will be going. Likewise, it will be going. So in the next slide, we shall see the working procedure of this program. So this is the working procedure of this program. We started with factorial of 5. Factorial of 5. Function call, through function call, we started with factorial of 5. When the n value goes here, this code will not be executed, this code only executed. It will return the value n into factorial of n minus 1. So what is n into factorial of n minus 1? 5 into factorial of n minus 1, that is 4. Okay. So, this is very, very important. This line, we got this line from this line. Hope you are understanding, right? When n is equal to 5, factorial of 5 is equal to 5 into factorial of 4, that is 5 into factorial of 5 minus 1. So, this is the case. Again it goes into R of C, recursive function call. So, recursive function call, again the value go to this factorial of 4. So, factorial of 4 is equal to what? This line, you just see here this line, 4 into factorial of 3, what is 4 into factorial of n minus 1, right? Factorial of 4 minus 1, that is 3. So, likewise the function call performed each and every time, the value will be what? Reduced. In one case the value will become factorial of 1. So, when we see this n is equal to 1, this else part will not performed, this part will be performed. Okay. So, if n is equal to 1, this will be equal to, this is 1 and this is equal to 1. So, this code will be executed. So, when one case is come, what is that case? Factorial of 1, it will return the value 1. When there is the final recursive call, factorial of 1, the value will be written as what? 1. Now, you see here, we know the value factorial of 1 is equal to 1. We do not know the value for this, we do not know the value for this and this and this. We do not know the value for this until this steps, but we do know the value of factorial 1 in this case. So, what is the value of factorial of 1? The value of factorial of 1 is 1. Okay, right. So, it is been mentioned here. The factorial of 1, it is substituted here. So, you take this line, the entire this line. Factorial of 2 is equal to 2 into factorial of 1. What is factorial of 1 value? It is 1. So, the answer is what? 2. 2 into 1, it is 2. So, what is the value of factorial of 2? Factorial of 2, the final value is 2. We shall apply this 2 to this thing, right? Likewise, we have to substitute everything and we get this answer. Factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24 and finally, factorial of 5 is 120. We have to just substitute the values, right? So, the final value, so the final value of factorial of 5 is what? 120. So, I hope you understand what is recursive function and the examples, the syntaxes. I hope you learnt a lot from this video lecture. Thanks for watching. Have a nice day.